So some examples of working with the trigonometric ratios, sine, cosine and tangent for right angle triangles, non-calculator and calculator based. So this was a non-calculator question, so it's asking us to write down the exact value of the tangent of 45 degrees. Well, we're expected to know what the answer to this will be, so we need a memory aid to help us. And what we need to remember is the tangent function. So the tangent of an angle, we call the angle theta, is equal to the sine of the angle divided by the cosine of the angle. And we need to remember that there's a little memory aid that helps us to work out the exact values we need to know without a calculator. So we have the sine of the angle, the cosine of the angle, and we have the square root of, and the ones we expected to know are 0 degrees, 30 degrees, 45 degrees, 60 degrees and 90 degrees. And this memory aid works by going 0, 1, 2, 3, 4 and then coming backwards 0, 1, 2, 3, 4, and then the answers are all over 2. So if I want the tangent of 45 degrees, then what that's telling us is that I need the tangent of 45, so it must be the sine of 45 degrees divided by the cosine of 45 degrees. Well, the way this memory aid works, guys, is I can see that the sine of 45 involves that, so that's going to be the root of 2, but then it's all over 2, so that's going to be root 2 over 2. And we can see that the cosine of 45 is also root 2 over 2. So we basically come to the memory aid, we find out the angle we want, and then we write the root of that over 2. That's the way this memory aid works, guys. Same thing divided by the same thing, then the answer is 1. So the answer to this question was 1. Just another example, just so you can see how it works. Say we wanted to do the sine of 60 degrees, then we look up 60 degrees and there's 3, so we know the top of the fraction is going to be the root of 3 and the bottom is always divided by 2, the denominator is always divided by 2. So that's how that would work. If we want the cosine of 60 degrees, then we would come to here, the cosine of 60 has a 1, so it's going to be the root of 1 over 2. Well, the root of 1 is just 1, so it becomes a half. And they actually tell us that one. They're being nice to us, but they could have expected us to know it as well. So that's how part A could be done. Part B, we have to work out the value of x. So we've got a right angle triangle. We've got an angle involved and a length. So that's shouting out at us that we're going to be using the trigonometric ratios. And most of us have a way of remembering the ratios and how they work. So car, tower is popular. So basically that's the sine, that's the cosine, and that's the tangent. And basically we interpret this as, for example, if we take this one, we interpret it as the sine of an angle is equal to the ratio of the length of the opposite length divided by the hypotenuse length. So you basically follow these round and then write down those. You can do them in a triangle. So the sine of theta is equal to O and H. So you can use a triangle to work out missing letters and that losing lengths if you need to rearrange. So let's have a look at how this gets labelled up. So for any right angle triangle, then we've got an angle theta, and opposite that length is known as the opposite length. So that's the O. Opposite the right angle is always the hypotenuse, so that's going to be the longest side of the right angle triangle, so that's the hypotenuse H. And the adjacent side, well, adjacent means next to, so that's going to be the adjacent side, so A. We follow through this mnemonic to decide which of these ratios we can use to help us solve this problem. Well, they've given us the adjacent side, so that means we can tick the A to say we've got that information. And the question wants us to work out the value of x, so they want us to work out the value of the hypotenuse length, so we also tick the h because we need to be working that out. Now we can see that from the mnemonic the only ratio that we've ticked twice is the cosine. So we can start out by writing out the ratio. So the cosine of the angle is equal to the adjacent length divided by the hypotenuse length. So we just follow the order of the letters. Cosine of the angle is equal to the adjacent length divided by the hypotenuse. We're told the angle is 60 degrees, so we shorten that to cos 60 degrees is equal to the adjacent length, which we're told is 4, and we want x. We want the length of the hypotenuse. Now they tell us that the cosine of 60 is a half, and that's 4 over x. So basically we've got a half equals 4 over x, and we know that to get that to become that we times by 4, so to get that to become that we times by 4, so x must equal 8, and because it's in centimetres it'll be 8 centimetres. Okay, so that's how that question could be done. If you weren't sure about how to rearrange and so forth, then again you could have written your triangle out. So cos theta is adjacent to hypotenuse. Because we wanted the hypotenuse length, then we would have covered that up, and it tells us to do the adjacent length divided by the cosine of that. So the hypotenuse is the adjacent length divided by the cosine of theta, which in this case would be 4 divided by a half. Well, 4 divided by a half means you double the 4, so you end up with 8. So whichever way you do it, you end up with 8 centimetres as the answer. So that's an example of doing trigonometric ratios without a calculator. Obviously, you hope that most of the questions that come up in your exams, guys, involve calculators, so we'll do this one using a calculator. Okay, so ABC is a right angle triangle, so we're already thinking it's about shapes. So what do we know about shapes? It could be Pythagoras, it could be trigonometry, it could be similar shapes, it could be congruent shapes. So we're kind of looking at other information. So they're telling us its length, they're telling us that angle C is 90 degrees, so in other words we have a right angle. So as soon as we start thinking to ourselves that we've got a right angle triangle with a length given, then it's likely to be about the trigonometric ratios. So car, tower, so sine, tangent and cosine. The size of angle B is in ratio to the size of angle A in the ratio of 3 to 2. So it looks like we've got to work out the length of AB. Right, so we've been told that was 90 degrees, and we've been told that the other two angles are in this ratio. So we know that these two angles must add up to 90 degrees. So angle B plus angle A must equal 90 degrees, because we know 180 take away the right angle. It's in the ratio of 3 to 2, so we've got B to A in the ratio of 3 to 2. Well, this means that 3/5 of the total must be B and 2/5 must be A. So it wants us to work out the length of AB, this length here. So it might be useful to know this angle here. So we'll work out the angle at A. So we want to do 2/5 of 90 degrees. So 2/5 times 90 is going to be 36 degrees. Okay, a fifth of 90 is 18, and double it, 36. So we now know that that's 36 degrees. Again, useful to add things to the picture to see what you're doing. Because we know this is about a right angle triangle, we've got angles involved and lengths, then we're using the trigonometric ratios. So we've written down our mnemonics to help us decide which is which. So we label this triangle. So here's our theta, the angle we're working with. So the opposite length must be over here. That's our right angle, so the opposite side is the hypotenuse, longest side. Next to the angle is our adjacent side. Now the question wanted the length of AB, so that's going to be that. So we've been told what A is, so we tick A, and we want to know what H is. Okay, so this one has come down to using the cosine function. So we write down what that is. The cosine of the angle is always the adjacent length divided by the hypotenuse length. Again, we just follow the order of the letters to write down the ratio. And we fill in what we know. So we know we're dealing with 36 degrees. We know the adjacent length is 14, and the question wants the hypotenuse. So again, you've got lots of ways of rearranging these, but if we think of this as what we're doing, then we want H, so we cover it up. So we've got to do the adjacent length divided by the cosine of 36 degrees. So h is equal to the adjacent length of 14 divided by the cosine of 36 degrees. So we make sure our calculator is working in degrees mode. So you should either see in your screen the letters DEG, short for degrees, or the letter D, short for degrees. Make sure that's the case. If not, learn how to reset your calculator. So we have to do 14 divided by the cosine of 36 degrees. So 17.3 to 3 significant figures, because the question wanted 3 significant figures. So the answer here was 17.304. Our first significant figure is the first non-zero digit in a number, our second one, our third one, so we're cutting the number there. So the answer will be 17.3 centimetres. And we ask ourselves, after doing all that work, is that answer sensible? Well, we know that we've been working out the hypotenuse length, the longest length of the triangle, 14 centimetres for that one, so this one's got to be bigger than 14. So again, that gives us a clue that we've done the right thing. It's important you do that, guys, because quite often in here, mistakes that sometimes happens is this is swapped about wrongly, and you end up with an answer less than 14. And that's because you'll have multiplied by the cosine of 36 rather than divided by it. So just be careful that you do check that your answer makes sense. Okay, so we've got a question here that talks about a right angle triangle. It's asked us to work out the size of an angle. It's a right angle triangle involving two lengths, so it could have been Pythagoras if it was asked to work out another length, but this question wants an angle. So a right angle triangle involving lengths and angles is shouting out at us, please use the trigonometric ratios. So SOHCAHTOA, sine, cosine and tangent, and we then go through labelling up. So it wants the angle ABC, so this is our theta, the symbol there means theta. Greek letter, we use that to represent angles, and we label up accordingly. So this is the opposite length, the hypotenuse is always opposite the right angle, so that's going to be the hypotenuse length, the longest length, and the adjacent length is next to the angle. In this question we've been given A and H, so we tick A and H. That's the only one we've been able to tick twice, so it's going to be the cosine function. So we write down what the cosine function is. So the cosine is equal to the adjacent length divided by the hypotenuse. And the question wanted the angle. So what we have to remember is, and one way to think about it is look at our calculators. On the button that had the cosine, there is also another label. Now quite often it's above the key, but on this particular calculator it's on the same key. And it's got cos to the -1, which is known as the inverse cosine function. So we've got to remember that when we want an angle, we have to do the inverse of the function. So this is the inverse cos function. So we do cos to the -1 of A over H. So we're going to be doing cos to the -1 or cos to the inverse of A over H. And we type that in our calculator. So we bring up the cos to the -1 function, and fraction 7 over 11, close the bracket and enter. So 50.47 degrees. Now we read the question carefully. It wanted the answer to one decimal place, so we must remember then to round this appropriately. One decimal place means one digit after the decimal point, so that's going to be 50.5 degrees. So that's one way we could work out this. Now the examples I've given just happen to all have been cosine, but just remember it's the same process all the time, but sometimes you might have had the opposite length in the hypotenuse and therefore you'd use a sine function instead, and on your calculator all the keys are always next to each other, so sine, cosine, tangent, so you've got to use the appropriate one. This question did go on though, and it talked about the length of the side AB is reduced by 1 centimetre. So our triangle has now got 10 centimetres there. The length of side BC is still 7 centimetres. Okay. This angle is still 90 degrees. it says, will the value of the cosine ABC increase or decrease? So in other words, this angle here, will it increase or decrease? Well, we can see that if we think about the function, we've got the cosine of theta is now equal to 7/10. Now, this all depends on how much you know about the cosine function. There's lots of ways of going through this question. You could actually work out what theta is by doing the cosine -1 of 7/10, and then of course that will tell you what's going on. So if we clear that, cos to the -1 of 7/10. So 45.6 degrees. And that would then say, well, I've calculated again and I've found out that the answer is less, so the value will decrease. So value decreases, and it says give a reason. Well, there's your reason. That's one way of doing it. The other way, well, another way of thinking about this is that the cosine function has its own graph, and the cosine function technically does this between 0 degrees and 360 degrees, and what we can see is that this was 90 degrees, then 7/11 is less than 7/10. So seven over 10 would be there, 7/11 would be there, and because 7/10 is less, it means it's gone that way. So in other words, the angle has decreased according to the graph. So again, that would be one way to explain it, that the angle will decrease. But working it out, because you've got a calculator for this question, and doing that, that would be fine as well. Okay, so that's just some examples of doing questions involving the trigonometric ratios and right angle triangles. Okay guys, good luck.